Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. All right, everyone. I am on the line with Manuela Veloso. Manuela is the head of AI research at JPMorgan Chase and a professor at Carnegie Mellon University. Manuela, welcome to the TWIML AI podcast.
Yeah, it's great to be here. Thanks for having me.
Absolutely. It is wonderful to get a chance to speak with you. You are currently in New York City, where you are recording this from your home on lockdown. How are things there?
So again, we are on lockdown. I'm in the apartment, and
Uh-huh.
I've been here for 3 weeks. But surprisingly, I continue to be very productive in terms of work because with all our virtual meetings, everything seems to be going quite well. What is challenging is to exercise and to make sure that you get some fresh air and some sun. So, but from the work point of view, I miss my team, but we have a lot of Zoom meetings
hmm
that seem to be very successful.
Did you work from home quite a bit beforehand, or is this a transition for you?
So, Sam, I came to the United States in '84, and I've never worked from home ever.
Wow.
I know, I know, I know. I mean, it was like these, getting up in the morning, making our bed, getting ready, and just leave every morning, and then come back in the evening. So this is quite new to me to be here at home every day, but somehow it has been working. Yeah.
Are you finding yourself more or less productive than like how do you compare your level of productivity with this new way of working?
I think that with the setup we created at JP Morgan, in which we try to have a lot of meetings so that eventually we see each other as often as possible, I think it's working fine. I mean, I'm not 100% sure in 3 weeks if we are still in the same productive chain, but I think we have been quite productive. I mean, more than what I thought the first couple of days. I thought I would like be eating all day in the kitchen or doing my laundry or something. What is this of being home? But
Uh-huh.
no, I'm in my office. I have the computer, and I'm literally in my office from 8 in the morning to 6 in the afternoon. So that's
Wow.
fine. Yeah.
Well, I'm glad to hear that everything is going well on your end.
Thank you.
Why don't we jump into your background? You are
Sure.
currently on leave from Carnegie Mellon, CMU, where you were faculty in the Department of Computer Science. Tell us a little bit about your background, how you got involved and interested and involved in machine learning research and your kind of broad research interests.
Yeah. So this is like very nice to explain. So somehow, as a kid, I got very much interested in math. Math was really what I like. Arithmetic, from arithmetic all the way to calculus or everything. Math is what I wanted, what I like to do. In fact, I thought I would become a math teacher when I was like, 14, 13, 15 years old. And but my father is a mechanical engineer, and my mom also kept saying, no, you should be an engineer. So I became an electrical engineer, and also very happy with the amount of math I had there. And it was very interesting. And okay, that's how I became an electrical engineer. And in fact, I am one of the people that I never read a single science fiction book. I didn't like science fiction movies. Zero, zero. So I'm not at all this typical kid that loves computers and robots and aliens and Star Treks and companies. Zero. It's true. It's true. I only cared about this math and what it could do for you in your daily life, and a lot of interested on teaching math to people. Very, very kind of thing.
Hmm.
And then when I finished, I'm just going to tell you what made me like a change in some sense. So when I finished my undergrad degree, I was still in Lisbon. So I am from Portugal, from Lisbon, and I was involved in a master thesis in electrical and computer engineering in a project that was in the early '80s, very, very innovative. in which we had to buy computers and automate the production of a company of a line. The actual there was a company that produced it freezers and refrigerators, just a manufacturing company, and all the orders, inventory tracking, everything was done manually. And so we were supposed to work on how do we computerize, digitalize all that. That's very early.
That sounds like a great project.
I know. I mean, this was fantastic. And then through this, through talking with people, so how do you represent these? How do you write that? How do you generate a list of parts? How do you do this? Or how do you do that? I became fascinated by what computers could actually do in terms of representing knowledge, in terms of search, in terms of learning from feedback, in terms of accumulating data in a digital way. I mean, so that was the beginning of AI for me, was basically this engineering of getting like the functioning that used to be done manually done by machines.
Mm-hmm.
So that's basically no really wanting to understand how does the brain work or how do nothing like that. It was this functional engineering goal of getting these computers to do more than just numerical computations, but to capture behavior, choices, learning, data. I mean, fascinating kind of like 2 years of my life in which I became in love with AI.
Wow.
Yeah.
And so that was after undergrad. How did you then
Yeah.
develop that interest?
So then I finished my master's, and for family reasons, we came to the United States, and I did another master's in computer science now at Boston University. And then I applied for a PhD in computer science, and I went to Carnegie Mellon. And at Carnegie Mellon, if you think about Carnegie Mellon, that's like I mean, without offending anybody, but in those days, that's the mecca of AI, you know. So it was Herb Simon there, Alan Newell, Raj Reddy, Jaime Carbonell, Tom Mitchell, Geoff Hinton in those days was there, Mark Raybert. I mean, it was all these people that thought nothing else than AI, literally. I remember when I came in '86, there was this meeting of the incoming students, and the faculty would present themselves, and there was Raj Reddy that walked into the room and said, "Hey, kids, imagine if all these walls, these cement walls, would be displaying live the best masterpieces of the Louvre." This was like before we even had wireless. I'm telling you, this was all about thinking big. And Alan Newell saying in 1987 or 86, what if all the people in their dorms could log into their computers and be able to know whatever is happening everywhere? And we were like, oh my God. You know, it's true. So I came here to the United States, first in Boston, and then I landed at Carnegie Mellon. And I thought, where am I? I mean, this world of computers doing it all was fascinating. At the same time that we were like trying to be Kasparov and all this chess playing and all sorts of, you know, anyways, Carnegie Mellon was for me, and I mean throughout the time I was there, like this place where we dream big and we get amazing things accomplished. And just so you know, actually also in 1986 when I came to CMU, there were already autonomous cars there. And in fact, there was this car that was coming down the campus. And in the morning, we would see by the library. And then in the evening, when we would leave, it had moved like, I don't know, maybe like 100 feet. I don't know. And it was supposed to be a big accomplishment that the thing had moved that far by itself. And this is the late 80s. So that's how I grew grew this passion for AI. Was a product of Carnegie Mellon and this
Mhm.
dreaming big of all the things that machines could actually do. And it was fascinating thing.
Well, it sounds like an amazing environment and time
Mhm.
to
Yeah.
be there. So fast forward to your faculty
Yes.
career. Tell us a little bit about your research interests.
Yes. So in some sense, I build an interest always on building complete AI systems. A lot of my research has been on trying to connect the perception part with the cognition part and with the action. Perception, cognition, and action. I think that first slide has been in my talk since for always, because in some sense, also following up on things that Alan Newell was telling us, AI has been a science of components: natural language processing, vision processing, planning, search, machine learning, speech recognition. So it has been a science of lots of interests, lots of dimensions. And I always thought that it would be good to put it all together as an agent that could do like the vision, and not just the vision to classify this as a cup, but then to pick it up, and not just to pick it up, but then to actually take it somewhere, and not to take it somewhere, but actually to execute, not just plan, but execution, and all the problems of perception, cognition, and action. And that led me to spend all my life building autonomous robots. So I've built a lot of autonomous robots, not necessarily autonomous cars. I never worked that much in outdoors robotics. I worked in indoor robotics, and my passion was not necessarily on manipulation, but on mobility. So from robot soccer to mobile robots in the environment, I've built, tons of different robots that moved, interacted with people, could see could see actually, could do perception in real time, detect an orange ball in RoboCup, or other things. I spent all my life building autonomous robots capable of this perception, cognition, deciding where to go, and actually going. And That's what I've done in the late 90s. We started mid 90s. So I co-founded this RoboCup initiative in which robots would play soccer in different leagues and all sorts of like different conditions. But basically, the fascination was the autonomy. Even today, when I look at videos from robot soccer, the only thing I appreciate is thinking done it was all done by an algorithm. It was all done by algorithms. It was all automated. It's not exactly just the learning part, but it's actually the ability to frame a whole problem into something that the computer can actually do from beginning to end. And that
Can you? I don't think we've talked about the RoboCup challenge on the podcast previously. Can you frame
Yes.
the problem for us? I think my exposure to it has primarily been through watching blooper reels, which probably isn't representative of
No.
the research accomplishment.
Yeah. So Robot Soccer started around like 94, 93, 92. And then the first actual competition, was in 1997 in Japan. And basically was so think about those days in the 90s. There was like the blooming of the internet, a lot of like uh, competitions on speech recognition, text understanding, and the physical world was not as much the focus in those days of what AI was doing. And robot soccer came about to address this problem of processing information, but at the physical world level. So robot soccer came about, in fact, as a challenge also for multi-robot reasoning. The robots had to work in a team. They had to be able to have an algorithm that looks at the playing field, and decides where to pass the ball, and eventually had a very concrete goal, which was winning. So you had
Mhm.
to really score these goals. So that has motivated thousands and thousands of people. RoboCup is, even as of today, it happens every year, and it brings people. It's limited the number of teams that can come, but it's more than 3,000 people every year that come from all over the world. And the beautiful thing about RoboCup is these autonomous. They are all autonomous. There is nobody joysticking these robots. There is nobody like telling anything to the robots. The complete system has to be autonomous.
Mm.
Anyway, at the beginning they barely moved. Now, yeah, it's true. They barely moved. We had a big problem with this connection of the perception and the reasoning. By the time we had the robot decide to go to the ball wasn't there anymore. So you had the camera that would process the image of the ball, but it was too slow, it was too noisy, everything was very hard to make the robot really act by processing its own images. Anyway, so that's a long story, and but on the other hand, it put me always onto this mode of getting things that work. And anyway, so that's went from there to having like cobots, which are these robots that move down the corridors at Carnegie Mellon. They have moved thousands of kilometers in our environments by themselves, not thousands, thousand and many, so 2,000, close to 2,000 maybe now. But again, like this goal of trying to put it all together: perception, cognition, and action, data, reasoning, and action. So the processing of the data combined with what we need this data for, and then eventually deciding and executing. So that was my life. That has been always my life. A lot of learning, but at the reinforcement learning level, learning at the action selection level, learning at the execution level, learning to improve perception with experience. Has been, I keep calling these learning from experience, not necessarily the technique itself, whether it was neural nets or decision trees or SVNs or whatever method we use, was more of this concept of learning from experience.
And so with kind of background and passion in robotics, how did you end up at JPMorgan Chase? I don't see many robots, when I go to the bank.
Wait one day. But I'm just saying. So that's very interesting. So it's true. I mean, I was quietly at Carnegie Mellon doing my research with a large group, many students, beautiful. And I was actually at the time in 2016, 17, I was the head of the machine learning department. And I got a call from JP Morgan asking, so telling me about these effort they were trying to start, bringing basically AI reasoning, AI research, really not just applied AI, but AI research to the firm.
Mhm,
And what actually made me come to JP Morgan, which I'm very happy to be here at JP Morgan Chase, was in fact the thinking like this: oh my God, this is a new area that I never thought about.
mhm,
And it was this fascination of thinking, oh my God, I have a chance of doing something in another area. It's almost as if robotics was beautiful. There was a lot to do, but I was at home in robotics. I mean, what
right, right.
more image, less image, more object, less object, more command, less. I mean, it's kind of like. But then it was this chance, and then there was this major comment from the leadership at J.P. Morgan Chase that made the difference. They said many of the companies, Google's, Amazon's, Facebook, Twitter, they were all born digital. They were all born thinking about machine learning, thinking about data, thinking about computing, thinking about algorithms. Everything was born digital. But all these other industries like financial, health, the construction, the cities, you name it, existed well before the computers existed.
Mhm,
So that was fascinating to me to think that I could come, and I'm here to try to see how to bring more AI. My experience of AI, building these systems from beginning to end, can make a difference in terms of like the financial domain. So that's basically what brought me here. And it was somehow a mixture of being afraid, being like apprehensive, and also an enormous excitement to be in a different thinking mode. That, so these are the two things.
and the group that you run there, it's a research organization as
Yes,
opposed to,
yes.
building churn models for credit cards or something like that.
Exactly. So we are a research group, and we try to focus on, how can I say, aspirational goals. We try to focus on things that would make an impact if they were solved one day. So, for example, if this is okay, I can just share a few of the goals. We'll just focus on a few, but
Mhm,
we kind of structure this AI research after a 1 year of being there, absorbing what this financial domain was all about, into 7 big research goals, which we call these aspirational goals, these big research goals. And they are like this. Three of them have to do a lot with the actual domain itself and the
Hmm.
issues of the domain. And so they are, so how do you use AI to really eradicate financial crime? Not to decrease the number of false positives or false negatives, the alerts, the frauds, the money laundering, but really to eradicate financial crime.
Hmm.
It's like the cure cancer kind of goal. How do you do that? So that's why it's part of their research. It's like, how do you eradicate this financial crime and use AI for that? Then another goal that is very important is this goal of like, how do we actually, we call it liberate data safely. How do we go about engaging with universities, making sure that people can help us, and even in the firm, we can all share data and can make secure computations in a way that's safe, private. I mean, another big goal. How do you go about doing this in a world full of like privacy issues and encryption issues and messiness of the data and ownership of data? How do we go about liberating this data safely? The third goal is the very interesting goal that has a lot to do with my robot soccer, one way or another, which is looking at this problem of the financial domain as a large multi-agent system. There are many interacting pieces. So we want to predict and affect these large, complex economic systems in a way that we can actually make a difference in terms of like understanding what makes them their dynamics and what makes them actually how do they function in such a complex way. And so we do a lot of simulations, very rich simulation, very multi-agent simulations, very much like trying to understand the components of these very complex global problem with all. And it's a, I mean, again, it's a huge goal. If we could one day understand how the multiple countries, the multiple parties, the times virus, no virus, how can these all these things affect the financial health of a society, of individuals, and what is this all about? So these three goals are very much like finance oriented goals. And then we also have three goals that are very beautiful too, because they capture the stakeholders of this financial domain. And basically, the stakeholders are your own employees, your clients, and the regulators. And so there are these three components that you have to care about and try to bring AI to improve the life of your own employees, to help them move up in the value chain. You want to perfect the experience of our clients, and you also want to be able to agentize or to be able to automate this policy understanding, this policy compliance, this policy compliance in some sense. So we have these three other goals that have to do with people, with rules, with handling, like how do we do the employees, the clients, and the regulators well. And the seventh goal is kind of an overarching goal, which is how do we make this AI be ethical and that and taking into account the social good of the whole story. So we have this establishing ethical and socially good AI as the seventh kind of overarching goal. So that's what we do at JP Morgan Chase in terms of AI research, is work towards these seven goals.
You spent the first year kind of studying the domain and articulating these goals, and you've been there a year and a half or so. Have you made much progress in any of these areas yet, or how are you? Where have you made the most progress?
So very good question. So as you can imagine, I started one person myself alone. Now, so yeah, but I that
Very different from CMU.
exactly. However, I was like surrounded by 250,000 people at JP Morgan Chase. So it was
Hmm.
kind of like overwhelming also the scale. But on the other hand, the JP Morgan Chase happened to have been it has been a delightful journey because of the support that the leadership and everybody has given to these kind of like AI thinking. So it has been very nice. So we are currently 30 people, more or less, we are 31 or 32 or 29, some with the offers we have. So somewhere around 30. And we kind of have worked in kind of like how we think about things is like all the projects somehow that we work on, be it like us thinking about things or like the business asking us to think about things, are all towards one of these goals, one way or another.
Hmm.
And now everything is in place. I'll give you example of two because I think maybe three, but I'll tell you one thing that is one example that is very nice. So basically, we knew. I'll give you this example first. We knew that the actual success currently a lot in machine learning had been like this neural net, the
Hmm.
deep learning. And we also I also know that deep learning is very successful on images in particular. So when I was brought to visit the traders floor, so I was in these in London. Actually, I was in London at JPMorgan in London, and they brought me to this floor, which is like, well, what we see in the movies, right? So everybody's surrounded by screens with all these little kind of like graphs on the screens, and people are making choices of sell, no sell, buy, no buy, who knows.
Hmm.
And literally I had this tour of that floor, and they were explaining to me all these things, and I was fascinated, but I couldn't see anything else but images. Those screens that people were looking at, they were not apples and orange, they were not cats and dogs, but they were these images of these little kind of graphs. And a lot of research has been done on applying math to predict and to this time series data, but I could only see images. So I went to my lab and worked with a few of my colleagues in those days, and we said, can we use these with a neural net to try to classify the images on their screens as buy, no buy choices? And we built this system, a fascinating system. We called it Mondrian. And we built this system. We were able to use those images, and with historical data on S&P 500 decisions, we were able to reproduce 95% accuracy by just using images on the buy, no buy choices that humans had made.
That is fascinating.
I know.
Surprisingly, it's counterintuitive. Like the images are, kind of dumbing down the data so that we as humans can interpret it. Why not just use the data itself?
Well, we could use the data itself, but it doesn't do as well. The data needs to be normalized. Like, it's more the shape that we are capturing, because the data, the value 5, 6, 7 doesn't, it's going to confuse a little bit the learning thing, while the shape was remarkable at capturing it. But on the other hand, if you use also a good representation of the actual numbers, it also works, except that because we looked at how humans made decisions based on those numbers, on
Mhm.
those images,
The images.
we then could do images for many other things that we have been doing that are not objects, like we have traditionally applied to, at least in those days, to deep learning, but they were images of other things, of other processes, of other images, of other visualizations, of other decision making environments. Think
Mhm.
about the doctor also. They basically can look at your EEG data and make a decision, normal, no normal, and that decision comes from looking at an image. And so it's fascinating. This concept was fascinating, and this concept of associating these time series data to an image that then you can actually classify for decision making. And we it's a that was a very nice project.
Is your ground truth in that example, is it the
What?
decisions that the traders
Yes.
made or the performance
No,
of
no, no,
those
no, no, no.
decisions?
No, 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 Sam. The decisions the traders made. We are not yet like beating the whole world by using these images. No, we are basically.
Well, I'm thinking of like all of the, the pictures of some of these financial, stock charts and,
Yeah,
how many different kind of voodoo incantations there are about this curve crossing that curve and this shape and that shape. And it sounds like you're
yeah.
in effect capturing some of that.
Yes, exactly, exactly. And I'm telling you, you cannot imagine how much information about that correlates with the decisions is visually visible. And in fact, you just said the crossing, the shape going up, going down, the other one coming up and down, is very visible in an image as a feature. And to extract that from data, from the actual numbers, is another representation that is more
Mhm.
that's different. So I basically build upon the success we knew that images had with machine learning to transform this problem into an image classification problem, an image understanding project problem. And it was very successful, and it has been very successful. And I'm telling you, we are now doing prediction basically by looking at what we don't know, but what are the images, what would the future, which image would be the future that less disturb. I mean, anyway, we are able to predict the images of the future. And so it's it's really beautiful. So that's like to show you that it's a transformational way of looking at something that is very classical, eventually making decisions by no by on time series data, but I looked at it as an image. So that was very
Mhm.
nice. Another one that's very nice, and then I will stop, is just that we also have been trying to understand this problem of client experience or fraud or all sorts of problems that we need to classify into. Let's think about fraud from a behavior point of view. And I give you an example that is very important for us to understand. So if you and I would have been asked to classify in New York City which of the cars are taxis and which ones are personal cars, 10 years ago, you and I could use only the color of the car.
Right.
You and I could say yellow taxi, non-yellow private. That's it,
Mhm.
right? So there was this classification based on this feature. If we are asked now which cars are service cars and which are private cars, the color doesn't help anymore only,
Right.
because basically there are all these Ubers, Lyfts, Vias, everything. So now it's a question of classifying behavior rather than just these one-shot features, because the behavior now is like, okay, this car went from here, stopped there, then went there, stopped again, has been goes like that. Oh, that looks like a service car, not a personal car. It's the behavior in some sense that helps us classify service, non-service. And we are trying to apply the same thing to problems that have been classified a lot by just looking at this particular transaction and deciding, oh, this is an amount, this goes to an account that we don't know, and just looking at that by building the behavior of these users to try to detect what can be eventually behavior that is not normal, behavior that is this that we can distinguish from other type of behavior. And
Mhm.
so it became not a classification only of the transaction or only of this snapshot, but we now, in terms of research, are building these representation of all these time dependencies, of all these connections in terms of knowledge, of all these graph-based representation to try to capture much higher level the to try to classify these fraud no fraud, to capture these complicated uh, classification problems. Very similar to the taxi versus no taxi or car service versus no car service in New York, the same problem. And so that's another example in which we have shown that indeed, by capturing how much of these nodes, these users in our network of interactions communicate with each other, and these accounts transfer from one to another, you are able to detect much better behavior that is not normal. So this is another example, and we have done also the third example I can give you just to finish these kind of like examples is that we have been also basically automating the generation of a lot of documents, either for regulators or for our clients or internally, PowerPoint presentations, representation, as a translation from data that is in some format like numbers, lots and lots and lots of information about transactions, into English, into another representation, charts, insights, comments. And we have been automating that kind of like description of the data in a representation that is readable or that is formatted according to what's required to show.
When you say translation, are you meaning that literally, like using a neural machine translation type of a tool and applying it to
Very good.
this particular scenario?
Very good question. In fact, we have not yet learned this translation. We are really just writing an algorithm to make the translation, computes basically all these. It's like you could think about these as a template filling, kind of like
Hmm.
a algorithm. The template is complex. Where do we get it? We had to represent it well, and then we feel, and then we are ready eventually at some point to do the learning of what these parameters should be and how the template should move and the personalization and who goes where. But it's
Hmm.
another level of learning. It's not really learning that, how do you say this word in a different language? But so we built the translation machinery, and now we have to adjust all the parameters of this machinery through feedback and through learning, yeah, through data, through the use of this. But we built the translation machinery. And that requires, so the beautiful thing about building this translation machinery is that we try to build it in a way that it doesn't apply only to a specific task. So it is general in terms of like different types of reports. So they all require eventually the data to come into this form. So you change the data and you manipulate these knowledge in a way that you can then automate. So, in some sense, I am, as you can imagine from my first days, I am always a, how can I say, an automation person. I'm more of an AI
Hmm.
engineering person. And then machine learning for me is like a tool to try to get these automation machinery adjusted and personalized and you
Generalized.
exactly, and generalized and
Hmm.
transferred and all sorts of things. But so the data plays the role for me as okay, now I adjust all of these, and this goes to that side, this goes to this side. So yeah, so that's what these are examples of the three projects: the Mondrian project, this kind of like behavior-based fraud detection, and these automation of reports out of several others that we have done. Yep.
And do you see your charter at the bank in terms of a time horizon? Like there are lots of embedded machine learning AI folks, I imagine, all over the bank, and
Yes. Yes.
trading organizations and client service marketing, et cetera, that are working on immediate projects. Or is one of the ways that you see your charter as being you're in, 5 to 20 year realization, or whatever the numbers might be?
It's a good question. So indeed, JP Morgan Chase is amazing in terms of how much machine learning is being applied throughout the firm. And
Hmm.
for classification of emails, for marketing decisions, for decisions on credit, no credit loan, all these are supported by data-driven algorithms. I mean, one way or another, they are present throughout. It's 50,000 technologists that JP Morgan Chase has, and
Hmm.
out of those thousands now or hundreds are AI and machine learning people very close to the business. Somehow we are building this understanding that we work close to them, and they work close to us when the problems are reach a level of complexity or of dreaming that cannot they don't have the immediate way of addressing them. We start a much better dialogue. For example, this Mondrian thing, or even like the generation of these documents automated or generalized and learning from the use, is like kind of something we are involved. It's not yet deployed. So it's while the applied machine learning, the applied AI, they actually are very close to the business and making sure things get immediately deployed. But our behavior, the research we do, these steps. I mean, think about the cure cancer problem. There might be steps in which you find better chemio. There might be steps that you find better devices, and they end up, getting to be in the hands of the practitioners. And so it's the same thing
Hmm.
with us. Same thing with us. For example, these things we are doing about behavior recognition and eventually understanding the network of interactions for fraud detection, it will eventually be is closer to deployment than other things we are working on. So we are in that spectrum, and and we interact a lot with the business. We interact a lot with our colleagues in applied machine learning, and but we still kind of live in this world of being free to, how do you say, to transform, to reinvent,
Mhm.
uh, to just think a little bit more without the boundaries of having something that is needed today. Now, whether it's 5, 20 years, I don't know, but I do expect to that we. So just so we know, I expect that we produce novelty and innovation every year. Every year we do something. When do we reach the goals? Who knows? I mean, in RoboCup, we used to say by 2050 we will beat the World Cup
Mhm.
human players. Robots will beat the World Cup human players, and we made that 2050. We are getting too close to that, but anyway. But I don't know exactly when we'll eradicate financial crime. But
Mhm.
we also, but these goals we built them to be like for 2030. And it's like
Mhm.
a 10-year goal in some sense.
But is your novelty and innovation metric is what is it, direct value to the business, meaning you've come up with something and they've implemented it and it's solving a problem? Or is it, is there a publishing model, for example, where you expect to be, publishing in academic literature and that's a metric for novelty and innovation?
Definitely the latter too. We have a lot of connections with universities. We publish all our results, so we want to be. We are involved in all the research activities, and uh,
Okay.
I could like tell you, Sam, a whole other conversation about our connections with universities, the fellowships we created, the research awards we created.
Mm-hmm.
I'm sorry I did not focus on that as much, but yes, we are literally a research group, and
Yeah.
so as such, we are a research group. However, I do believe that that we make a difference also at another level of value to the company. Oh, we bring talent. It's a very good we a very good benefit for our firm. A lot of talent in this computer science core and AI core, and machine learning, AI, and computer science, computer engineering.
Awesome. Are there any particular places that we can look for publications or some of the
Yeah,
work that you're doing?
yeah, yeah. There is we have an external website with all our publications, and I can text to you, but I believe it's just JPMorgan/AI, or JPMorgan Chase. I forget now. I have it the bookmarked, but
We'll chase it down and include it in the
yeah,
show notes page.
perfect. And it has all this description of the goals, the publications we've done, these different pillars, everything. Okay.
How do you see the role and the group evolving? Again, you're kind of recently having established these principles and kind of getting underway. You've grown pretty significantly. What do you expect to see over the next few years?
So we are a group of basically me heading, and then I have three research directors. Tucker Balch, who came from Georgia Tech, Prashant Reddy, who came from Google, and then Samina Shah came from S&P 500. And basically, the three of them and me are the directors of this group. We have only masters and PhDs in my group, masters level and PhDs, and we expect to grow by next year to be a group of probably 50 by the end of this year, and then probably grow up to be 100 within the next 2 3 years, and stay at 100 150 within JP Morgan doing research, AI research in the financial domain. So anyone who has an interest on doing AI research in not only, I mean, or wants to consider not only the technical, the tech, the giant tech, the Googles, the Facebook, and Amazon, and so forth. This is a great place to be to do AI research in this particular kind of like financial domain. But in great, so we publish in great through AI research and AI and machine learning. So that's what I'm trying to build is a little AI research group, up to 200 people, I would say, within the next 5 years.
Well, Manuela, thanks so much for taking the time to chat with us, share a bit about what you're up to. It was great meeting you and great learning about what you're doing.
Thank you very much, Sam, and thanks a lot for hosting me.
Absolutely. Please be safe. All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in this interview, visit TWIMLAI.com. Of course, if you like what you hear on the podcast, please subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.